New result of a 10 years AI made by NVIDIA. Hey everyone, welcome to our channel. If you're new here, welcome. And consider subscribing to my channel and click that little bell notification below. AI is everywhere. It's already working with us and even guiding us sometimes. But when talking about AI, we must talk about NVIDIA. NVIDIA Corporation is a software and microchip firm that creates graphics processing units, application programming interfaces, and much more. Simply, it's a leading manufacturer of artificial intelligence hardware and software. The reason for this video, as you already know, is the news that NVIDIA could train an AI agent in 10 days to get an experience worth 10 years. Then we all got the question, how? After 10 years of training, NVIDIA's virtual characters could perform nearly perfect physical simulations of lifelike behavior. They accomplished this by providing them with enormous unstructured motion datasets to train on. NVIDIA AI Lab uses its own framework to train these characters over 10 days, which equates to 10 years in virtual world simulation. Humans can do an incredible range of complicated activities by drawing on a large repertoire of motor skills. This repertoire is developed via a lifetime of engagement with the environment, resulting in general-purpose skills that can be widely repeated to complete new activities. This violates common practice in physics-based character animation and reinforcement learning. So, creating more versatile and reusable motor skill models can allow agents to solve tasks that would otherwise be too difficult to master from scratch. To fill this gap by giving human-like abilities to the characters, scientists at NVIDIA invented Adversarial Skills Embedding, or ASE, a scalable data-driven approach for learning reusable motor skills for physically simulated characters. So let's see what's in their research paper. The AI training method is divided into two stages: pre-training and task training. During pre-training, the character is given a collection of motion clips that demonstrate the kind of behaviors that the agent should learn. Each motion clip is represented as a series of states depicting a certain behavior. An adversarial imitation learning approach uses this dataset to train a low-level skill condition strategy that maps latent variables to behaviors that match the motions exhibited in the dataset. The low-level policy is then employed to execute new tasks in the task training stage by training a task-specific high-level policy that defines latent variables for guiding the low-level policy toward accomplishing the task objectives. The high-level policy is based on a task-specific goal and can be taught in the absence of motion data. However, because the low-level policy was trained on motion data, the character can create naturalistic actions even in the absence of motion data. To test the framework's usefulness, they used ASE to create reusable motor skills for a complicated 3D simulated humanoid character with 37 degrees of freedom. A 3D spherical joint connects the sword to its right hand, and a fixed joint connects the shield to its left arm. They tested reaching, speed, steering, targeting location, and striking with the model. Yes, they were successful in training the agent with 10 years worth of experience in 10 days. But of course, it wasn't as perfect as humans are. They said that while the framework can use massively parallel simulators to train skill embeddings using years of simulated data, the method is extremely sampling intensive compared to the efficiency with which humans can explore and learn new skills.